Have you ever wondered how electricity flows, or why some materials conduct electricity and others don't? Well, you're not alone. These questions have intrigued scientists for centuries, and the answers lie in the heart of our modern world. Today, we're going to explore these questions and take a journey into the captivating world of electricity. Our journey will take us across three key concepts: conductors, semiconductors, and insulators. These terms might sound technical, but they're actually quite simple. Conductors are materials that allow electricity to flow through them with ease. Semiconductors, on the other hand, are the middle ground. They can conduct electricity, but not as well as conductors. And then we have insulators, which resist the flow of electricity. Understanding these concepts is not just important for scientists or engineers, but for anyone who uses electricity, which is basically everyone. So, buckle up and stay tuned as we delve into the fascinating world of conductors, semiconductors, and insulators. Imagine a bustling city with people moving freely. That's a conductor for you. A conductor is a material that allows electric current to pass through it with minimal resistance. It's like a superhighway for electricity. Let's delve a bit deeper. At the heart of a conductor's ability to allow the flow of electricity are free electrons. These are electrons that are not bound to any particular atom. They are free to move around within the conductor. When a voltage or electrical force is applied to the conductor, these free electrons are pushed along, creating an electric current. Think of it as a crowded dance floor. The dancers are the free electrons, and the DJ's beats represent the voltage. When the music starts, the dancers move in response, just as electrons move when voltage is applied. Now, what materials make good conductors? Metals are the poster child for conductive materials. Copper, for instance, is a common conductor used in electrical wires due to its high number of free electrons and its ability to resist corrosion. Other examples include silver, which has the highest conductivity of any element, and aluminum, which is lightweight and cost-effective. Gold, while not as conductive as copper or silver, is often used in high-quality electronics because it doesn't corrode or tarnish. This means it can provide a reliable, long-term connection. But conductors aren't just metals. Some liquids, like salt water, can also conduct electricity. Even you, believe it or not, are a conductor. The human body, comprised mostly of water and minerals, can conduct electricity, albeit not as efficiently as metals. Understanding conductors is key to understanding how our electric world works. From the wiring in our homes to the devices in our hands, conductors are the silent heroes, making it all possible. So next time you're using an electronic device, remember, it's the conductors that are making the magic happen. What if we need something between an insulator and a conductor? Enter semiconductors. Now, semiconductors are quite the chameleons of the electrical world. They are neither complete conductors nor total insulators. Instead, they are somewhere in the middle, hence their name, semiconductors. You see, semiconductors have the unique ability to change their behavior under different conditions. They can conduct electricity under certain circumstances, such as when heat, light, or electrical field is applied, and act as insulators under other conditions. This characteristic is what makes them so useful in electronic devices. Here's a fun fact. The most commonly used semiconductor material is silicon. That's right, the same stuff that makes up a good chunk of the Earth's crust. It's chosen because of its ability to withstand high temperatures, its abundance, and its excellent semiconducting properties. Now let's delve deeper into how semiconductors work. At absolute zero temperature, a semiconductor acts as a perfect insulator. However, as the temperature increases, the atoms in the semiconductor material vibrate more, and some of the electrons gain enough energy to jump from the valence band to the conduction band, creating what we call electron-hole pairs. This process allows the semiconductor to conduct electricity. The magic doesn't stop there. Semiconductors are also the basis for the creation of transistors, the building blocks of all modern electronics. Transistors are tiny switches that can turn on and off billions of times per second, enabling the complex computations that power everything from your smartphone to supercomputers. Without semiconductors, we wouldn't have digital watches, calculators, radios, televisions, or computers. They've even made their way into our cars, helping to control everything from fuel injection to anti-lock brakes. It's truly astonishing how these tiny components have revolutionized our world. In conclusion, semiconductors are the jack of all trades in the electrical world. They can behave as conductors when we want them to, and switch to being insulators when we need them to be. This unique ability, coupled with their role in creating transistors, makes them indispensable in modern electronics. Semiconductors, as you can see, are the flexible middle ground, making them the heart of modern electronics. Imagine a city under lockdown with no one allowed to move. That's an insulator for you. Insulators, in the context of electricity, are materials that do not allow electric current to flow through them. This is because they lack what we call free electrons. These free electrons are the main drivers of electric current in materials. In insulators, the electrons are tightly bound to their atoms and cannot move freely to carry the electric charge. It's as though the electrons are under strict lockdown, forbidden from leaving their homes. Take rubber and wood, for example. They are excellent insulators. If you've ever wondered why electrical wires are coated with rubber, it's to prevent the electric current from escaping and causing a potential shock. Similarly, wooden poles are often used to support power lines, keeping the electricity contained and the surrounding environment safe. So, while conductors and semiconductors help power our world, insulators keep us safe from it. So, we've taken a quick journey through the world of conductors, semiconductors, and insulators. Let's quickly recap what we've learned. Conductors, like metals, are the highway of electricity. They allow electric current to flow freely, powering up our homes, our gadgets, and essentially our lives. Semiconductors, on the other hand, are the traffic controllers. They're found in every electronic device you can think of, from your smartphone to your microwave, controlling the flow of electricity and enabling the functionality of these devices. Insulators, like rubber or glass, are the barriers. They prevent electricity from going where it's not supposed to go, keeping us safe from electrical shocks. Together, these three elements form the backbone of our electrified world. Each of them, in their own way, contributes to the smooth functioning of our modern world, letting us enjoy the conveniences of technology safely. Understanding these concepts gives us a new appreciation for the electrical world around us. Thanks for joining us on this enlightening journey.